Alrighty, moving right along to section 8.7, factoring ax squared plus bx plus c. So factoring quadratics again, but this time we're going to have a number in front of the x squared instead of having the leading coefficient be a 1. So only one new vocabulary word. Most of this video will focus on the techniques used to solve and factor these problems. So first vocabulary word, a prime polynomial. This is any polynomial that cannot be factored using integer coefficients. So we'll learn later on that all quadratic functions can be factored, but sometimes the answer will come out to be an irrational number, like a square root something, or even an imaginary number, which we won't talk about till much later. But all of them can be factored, but only some of them can be factored using integers. So right now, at least at this point, we're going to focus just on factoring with integers, and if you can't find any integer factors, then we're going to call it a prime polynomial and leave it as is. Okay? So there are two methods to factor ax squared plus bx plus c. I'll write it here just to refresh your memory. So this is what we're trying to factor, ax squared plus, plus bx plus c. Now, if a was a 1, we were looking for two numbers that multiply to c and add up to b. But if a is not a 1, then it makes things quite a bit more complicated. So if both a and c are small or prime, then I'm going to teach you the guess and check method. Okay, so I call it the smart guess and check, because even though it is guess and check, you have a pretty good idea what the answer has to be. So first we want to list the possible factors of a and the possible factors of c, and then you can plug them in. So we have a, so you'll list all the factors of a here, and you'll list all the factors of c here. Now you can write down your parentheses like this, and these first two numbers here and here, these have to multiply to a, and then the back two numbers have to multiply to c. Okay, so you only have a couple of choices here if a and c are small or prime. If a and c are large and not prime, then there's a whole lot of choices, and guess and check will take a long time. But as long as, like if a is 2, the only thing that can multiply to 2 is 2 times 1, so that you know you could put a 2 here and a 1 here. For example, if c is a 5, the only way to get a 5 is a 1 times 5. So you could put a 1 here and a 5 here, or a 5 here and a 1 right here. When we do examples, this will make a little bit more sense, but the idea is you just pick out what possible combinations will work, plug them in, and the way that you check is by distribution. So you check by distribution. So once you've plugged in your guess, you multiply it out using FOIL or rectangle diagram or distribution, and you see if it works. If it doesn't work, you try something else. The reason I call it smart guess and check is because by looking at the possible combinations, you can see really easily that some of them might not work and some of them are going to be, better than others. So it's usually pretty quick and pretty easy to figure out what the answers are going to be, since we're only looking at integer solutions. But if you don't like guess and check, we always have method 2. So method 2 is best if a and c are large or non-prime, but of course it works regardless. Here, let me write down what we have again, ax squared plus bx plus c. So we're going to break this middle piece into two pieces that satisfy the following conditions. The two numbers that we break it into, they have to add up to b, of course, because we're breaking it apart, but they have to multiply. Instead of multiplying to c, they have to multiply to the product of a times c. So the first thing you want to do is write down the product of a times c, then find two numbers that multiply to that product and add up to b. Once you've broken this apart, so then you'll have ax squared plus b1x plus b2x plus c, then you can factor by grouping. You can group these two together, and you can group these two together, and you can solve using factor by grouping. And again, once you've finished factoring, always check your answer, very, very important, by using FOIL or distribution. So, but that's the explanation. Let's see some examples and then review the explanation. Alright, factor each polynomial if possible. If it cannot be factored, write prime. So I'm going to try the first one here, using the guess and check method. The only way to multiply and get a 2 is 2 times 1. The only way to multiply by, or to get a 2 here, is to multiply 2 times 1. So I have the first set of parentheses. I can plug in here 2x and x, because that's going to give me 2x squared, so first times first. Now, the 2 and the 1 that I have to plug in the back, I know it has to be a 2 and a 1. That's the only thing that will give me a 2. But I don't know whether the 2 goes here and the 1 goes here, or vice versa. So let's check both. Let me write down a second set of parentheses. We know this is 2x and an x, so it could be 2 and 1, or it could be 1 and 2. And everything is positive, so it's definitely positive, positive, positive everywhere. So how do you tell which one is correct? They both give you 2x squared at the front. They both give you positive 2 at the back, but it's those middle terms that will tell you the difference between these. So let's check our outers and our inners. Here, the outers give us 2x times 1, and the inners give us 2 times x. So 2x plus 2x is 4x. This one does not work because we wanted 5x. Here we can check the outsides. 2x times 2 is 4, and 1 times x is 1, so this is a 1x plus a 4x, which is 5x. So this is the correct answer. Okay? That's the way you can do it using guess and check when the first number and the last number are small or prime. Let me show you the same exact problem again, but using the method of breaking the middle thing in half. So the first thing you write down is so I'm going to solve this one again, but I'll solve it right here. The first thing you write down is that they have to add to the middle number, which is 5, and they have to multiply to the product of A and C. So they have to multiply to 4. Okay, what two numbers add up to 5 and multiply to 4? The two numbers that do that are 4 and 1. Okay, so we break this middle piece into a 4x and a 1x. So here's what we can write. We can write 2x squared plus 4x plus 1x plus 2. Now we can factor by grouping right here and factor by grouping right here. The first two terms share in common a 2x, so I can factor that out, leaving behind in the first one an x, and in the second one a 2. In this one I can just factor out a 1 because that's all they have in common, leaving behind the whole thing, x plus 2. And now you see they both have the x plus 2, so I can factor the x plus 2 out to the front, leaving behind the 2x here and the plus 1 here. And of course, you see we get the exact same answer. You could FOIL it out to check and make sure. Personally, I'll be completely honest, I like the guess and check method better. I really do. To me, it's easier and quicker because I've practiced FOIL a lot, and so I can check them very quickly. However, this is another choice that the book emphasizes a lot, so it's worth knowing that it exists. Okay, let's try one more. Let's try number 4. So the possible factors of 3 are just 3 times 1, and the possible factors of 2 are just 2 times 1. Okay, so we can set our parentheses up. We can put a 3x, actually it's a g, isn't it? We can put a 3g right here, and a g right here, because these two multiply together to give me the 3g squared. Likewise, I want to get a 2 right here, so a 2 times 1. Notice that they multiply to a positive number, but the middle term, when I add them all together, is going to be negative. So that means both of them are going to be negative. So a negative number and a negative number. Now, it's either a 2 here and a 1 here. So it's either a 2 and a 1, or it's a 1 and a 2. Before I actually plug them in, let's just use our simple thought process and see. If I put the 1 right here, it's going to get multiplied by 3. And then the 2 will get multiplied by g. So I'll have from the outside 3 times 1, and from the inside 2 times 1, which is a total of 3, and 2 is 5. If that's not good. If I put the 2 right here and the 1 right here, on the outside I have a 3g multiplied by 2, that's 6, and then on the inside I have a 1g, which is 1, 6 and 1 is 7. So my final answer, 3g minus 1 multiplied by g minus 2. Okay, so you can factor these using the guess and check method. It's pretty quick, I think, when the numbers are small or prime. Let's go on, one more example here. Let's do we'll try this one. Okay, this will be a little bit harder because there's an 8. Now we want to solve each equation. Notice that because this is equal to 0, once I factor this side, I can use the zero product property to actually get my answers. Okay, so we're going to try this one, and let's try it both methods. Let's try the guess and check method first. So my possible factors are 3 times 1, but to get an 8 I could use 8 times 1, or I could use 4 times 2. So there's a little bit more choices here. So we make our parentheses because we're factoring. 3W and 1W in the front, so 3W and 1W. Now I know I want to get a 14, and a 14 is a pretty big number, right? Whatever number I put here is going to get multiplied by 3. Whatever number I put here is only going to get multiplied by 1. So if I put a little number here, there's no way I'm going to be able to get 14W. So the two big numbers I can choose from are an 8 and a 4. If I put an 8 right here, 8 times 3, that's 24. That's way too big. But what if I put a 4 right here? Okay, 4 times 3, that's 12. Great. And if I use a 4 and a 2, I could put a 2 right here. Positive, of course, because these terms are all positive. So 2 times W is 2W, and 3W times 4 was 12W, and these two add up to give me 14W. So I have 3W plus 2 multiplied by W plus 4 equals 0. Now I'm not done yet. I've factored it, but I want to find the actual solution. So I need to set either this term equal to 0 or this term equal to 0. So I can do 3W plus 2 equals 0 as one option, and the other option is W plus 4 equals 0. So this is an easy option. W just equals negative 4. Very easy to see. It's the opposite sign there, because when you plug it in, a negative 4 and a positive 4 cancel. Over here, because there's a leading coefficient, the answer is definitely not just negative 2. Okay, sometimes you think, oh, it's just the opposite of whatever I see here, but because there's a 3 here, we have to do an extra step. So subtract 2 from both sides, that cancels, but then you have to divide by 3. Divide by 3, so W equals negative 2/3 is going to be our final answer. So based on this whole starting problem, number 16, 3W squared plus 14W plus 8 equals 0. If I plug in negative 2/3 and I square it and multiply it by 3 and plug it in here, and I work this all the way out, I will get exactly 0. Or if I plug in negative 4 and I work this completely out, I'll get exactly 0. So these are called zeros of the function, or solutions of the equation. And it's very important to be able to find them, because where the equation has zeros is usually the real-world meaning of whatever word problem you're solving. If you want to finish the video now, you can. If you want to see one more example, the same example but done using the method of breaking the middle term in half, you can do that. So we want the two numbers to add to 14. So same example but done a different way. And we want them to multiply to the product of the first and the last. So 3 times 8 is 24. So what two numbers add up to 14 and multiply to give us 24? Okay, so the answer is 12 times 2. One way to do this is just write the factors, right? So we got 6 times 4, 12 times 2, and 24 times 1, and 8 times 3. Those are all the ways that you could multiply and get 24. Which one of them adds up to 14? Definitely 12 and 2. Now we break this guy, so we have 3W squared plus 12W plus 2W plus 8 equals 0. So I took this middle term and I broke it into these two pieces. The reason I did that is because I can factor by grouping this one and this one. So here, they both have in common a 3W, leaving behind, if I divide by 3W, I leave behind a W. If I divide here by 3W, I leave behind a 4. Plus, here I can take out just a 2, leaving behind a W and a 4. Okay, now they both have the W plus 4, which can again be factored out. W plus 4, leaving behind 3W plus 2 equals 0. And from this point, obviously, we have the same solution that we had over here, and you branch it out and you get these two solutions. So same answer, different method. It doesn't really matter to me which one you pick, as long as you're able to show your work and logically explain what you're doing. You know, if you just jump from this first step all the way to this last step, that's no good. You have to show, okay, what am I looking for? How am I using those numbers to plug it in? How am I simplifying it? And how am I getting my final answer? Either by showing your guess and check work and then checking it by actually showing, like, what do you get when you multiply it out. And it's really important to actually check your answers. If it's a quiz or a test and you finish early, you know, there's no reason not to go back through and foil these and make sure you got 100%. So I know this is a tricky topic. It's one of the harder things that we're going to learn in the coming month or two. So, you know, take a close look, give it your best shot, keep on practicing, and we'll go over some more examples in class.